This is a topic that I feel kind of passionate about. I think it's extremely enjoyable and fun. And I don't know, I keep my mind open to the possibility that maybe we could integrate this into some of our work. I thought I'd start off with just a real quick intro. I think maybe it'll help us kind of connect, or at least you'll remember who I am. So I've been working at More Good Ideas for about 20 years. I think it's 19 and a half right now. I've done a lot of software control for manufacturing and a lot of like aerospace type industry stuff, and even got a little bit of ground support stuff for the A-10, which is fun for me. And this is a picture of me completing my 6th Ironman last at Coeur d'Alene in 2021. So that was, super slow. You can see my time on there. And the cutoff is at 17 hours, so I had 26 minutes to spare. I also am really passionate as just a personal interest in space exploration, and back in July even on launch day, we had a New Horizons party at my house, and then another New Horizons party in 2015, and this was our Pluto cake that we made, a nice spherical cake. And so something that I'm really interested in, as I was trying to think of something I could maybe mention for our Giants Are Female, I was just curious to see some of the women that had been involved in the success of that mission. And here's a picture of the female portion of the flyby team. About 25% of the team was female, and Alice Bowman in particular, her right here in the upper right, she was the mission's operations manager, which more or less meant that anything that anybody wanted to ask the spacecraft to do had to go through her, and she needed to make sure that it was really going to do what we wanted it to do. So she personally read every line of code before sending on 4.5 light-hour journey to get there and make whatever changes and updates they needed to do for the spacecraft. So to me, pretty cool stuff. It'd be so cool if you could send a message that far away. So what am I trying to do in this presentation? I'd like to just kind of explore a little bit what it would take for us to get involved or get started using Maker microcontrollers, and maybe we could even integrate some of that a little bit with our LabVIEW work. And I've got some demos so that we can have a chance to play around together with it. In fact, I'm hoping that that we can kind of have a collaborative or at least a participatory presentation today. So I got a few ways that you can do that, and I hope you'll make an effort to play along with my games. Also, it is a potentially broad and deep topic, and so I've tried to make reasonable assumptions and explain the things that I think need to be explained, but if anyone feels like they're getting a little bit lost or not able to follow what I'm doing, I hope you'll feel comfortable raising your hand, and I'd be more than happy to stop, backtrack a little bit, and make sure we're all coming along on the ride together. So if we're contemplating doing something with a hobbyist level microcontroller, what are the pros and the cons of doing that? I think that some of the pros are pretty obvious, that these controllers, they support lots of peripherals, right? You've almost standard on almost all of them. You're going to have multiple UARTs, multiple I2C, multiple SPI. Sometimes you'll see CAN, sometimes you'll see Wi-Fi, occasionally Ethernet or Bluetooth, even more exotic things like LoRa and others. That's not by any means an exhaustive list. They have, honestly, really quite impressive performance capabilities as far as processing, and they're easy to get. Tons of available sensors and actuators and things that you can hook up to it, screens and all sorts of stuff. They're really cheap and lots of fun to do all this stuff. On the other hand, partly because of the fact that there's so much stuff going on, it can be a very complex, confusing, difficult to navigate environment of figuring out what you really need, what you can really do, how do things hook up, how does it even work. The documentation for things is inconsistent sometimes. You don't always know exactly what the devices can do and how to operate them. So you may also have to learn some new things. You might have to learn new programming languages or new programming environments. There's so much stuff that it can be hard. And also, you buy something from NI and it's got like certifications and they've done all kinds of, interference testing and stuff like that. But if you're just cobbling something together, then, obviously you don't have any of that. So pros and cons. Here's not by any means an exhaustive list, but just to give you kind of a feel for the spectrum of things out there. There's so many people, so many companies, so many suppliers that are offering various products of various kinds. And each one of these companies, they don't have just a single product, right? There's going to be a whole product line. So trying to filter through all the different things that you could potentially use can be daunting from time to time. And then when it comes to software, you've got a similar landscape. I've kind of tried to organize these things from maybe more bare metal type things to interpreted type stuff that you could consider using. And then GitHub I just kind of put in the middle because who knows what you're going to find there. There's a huge resource there. Sometimes hard to find what you want, sometimes hard to know if what you found is what you want. But most of the time you can find something there that'll help you out. Okay, so I wanted to do a little intro on, you see I've got a small demo set up here. And so I want to just kind of walk you through, a little bit what we have here. So it's just a little off screen, but you can see this big light bulb here at the end. And that's just getting fed basically mains power. That's coming in through these connector blocks and into a relay. I used a 4-point relay because that's what I had, but I'm really only using one of them. And then this relay is getting some power from this little low voltage power supply right here. And we're powering our relay. And then we just have this one input bit that's coming out of this Raspberry Pi Pico. The Raspberry Pi Pico is also connected up to a couple of things. I've just got a little button here, which is connected to the reset pin, because by default, I forgot to hook up one important thing now that I'm looking at it. The actual micro USB, that would be good. So we've got the micro USB coming in here, and the normal way that you might reset it is to just sort of unplug it and plug it back in, and that's inconvenient to do. So I just have that button set up as a convenience. And then we've got, this is called a digital humidity and temperature sensor, or DHT, and it'll just, like it says, detect the humidity and the temperature. This particular model that I've got here is a Raspberry Pi Pico W, so it has this wireless chip right there. And and then this last thing that I've got is these two connectors are for this USB to serial adapter. And the reason that I'm using that is because I want to be able to have kind of two ways to talk to this Raspberry Pi Pico. Normally, when you plug in the USB, it, among other things, has internal to the Pico USB to serial adapter in there. So there's going to be kind of two serial ports the way I've got this hooked up. We've got the one sort of default, and then I've got an auxiliary one connected up. The normal one, the default one that's through the USB, you can kind of think of that as sort of like the standard output, whereas this other one is going to be just on UART1. And I'll explain how that all fits together in just a moment, but I wanted to kind of upgrade from the standard blinking and LED, so we're going to go for a full light bulb here. Okay, so let me get back here. And now, Jim yesterday already kind of went through a really good explanation of a lot of the features of the Raspberry Pi Pico. It was really just kind of an accident that he and I both, I guess, enjoy this particular microprocessor a lot, and I'm going to be using this specifically for my demo today, but probably everything that I'm going to show with only very minor modifications, probably just for like pin numbers, if anything, would probably work on many other microprocessors that can support MicroPython, so like an ESP32 or something like that would work fine. The two things that I did want to point out here, though, is that lots of these pins, I don't know if you've looked at these diagrams before, but pretty much every pin has multiple purposes, right? So in software, you can determine whether you want pin 1 up there in the top left corner to be used as just a general purpose I/O and GP0, or if you want to use it for SPI or I2C or for a UART. And so that's why in my demo here, we're using GP4 and 5 for UART1. Okay, so now we know what we're looking at. And I wanted to explain a little bit. So for my demo today, there is more than one way that you could program this particular microcontroller. But what I'm going to demonstrate is using MicroPython. And so the way that that works is you've got your sort of bare metal, you've got the basic hardware, and then someone has written a MicroPython firmware, probably, I think it's written in C. And then once they've written that, you can load that firmware onto your target, assuming you have enough memory and other resources for it. And then once you've got that, then you can have your client MicroPython code get loaded onto that firmware, and it'll execute it for you, and you can run your program that way. And that's so the code that I'm going to be showing you is just the MicroPython code, client MicroPython code to run on there. So if you had just, say, an entry-level $4 Pico chip or microcontroller, then you could potentially try to communicate with it over serial from LabVIEW, right? And so this is kind of a block diagram of what we're going to try and do with our demo. So how this will work is the microcontroller will talk to the DHT sensor and also through this one GPIO pin out to our relay to be able to turn on and off lights. So those are the two kinds of interfaces that we're going to have to be able to read some data and control some output. And then through our serial here, we should be able to make requests and receive back some information from our microcontroller if it were doing something. So first, let's look at how we would want to set up the code on our microcontroller. So there are a lot of different environments for doing MicroPython programming. There's Visual Studio Code plugins and other more dedicated development environments. But this is, I think, kind of sort of an entry-level development environment called Thonny, and it's specifically made for this type of thing, doing MicroPython development on microcontrollers. And so what we can see here, I should have specified one thing. So those two serial ports, the one that's just the USB is plugged right into the controller, that's COM3, just as how it happened to get recognized on my computer, and our secondary one is COM4. So if we look here in the lower right corner of Thonny, we can see that this has detected that we have a MicroPython Raspberry Pi Pico on COM3, and if We disagreed with its auto detection. We could pick something else, but I'm pretty happy with that. It's on COM3. So we're going to leave it there. And I've tried to make the font big enough so that people can see what we have here. And I'm going to switch over to this file because that's the serial demo. And one of the great things about working with these kinds of controllers is that there's already so much stuff out there that we can use. And so we don't have to write extremely low-level code, generally speaking, in order to do what we want. And this is kind of a little bit where that magic is going to happen. So we've found a few libraries that are going to be useful for us. And because of those libraries, we can just interact at the library level, and we don't have to be quite as low as we maybe otherwise would. So these are the things that we're going to need. We're doing some time stuff. Obviously, we want the DHT library. This is a regex library that we use for one part just to help us format some strings. And then the machine pin part is for us to control that output pin. We're just going to create a digital humidity temperature sensor. We're going to keep track of some time. We're going to create a pin for our light. We're going to set up our serial interface so that it'll talk to us when we want to. And then we've got some regex for parsing commands. And I've got a couple of function definitions here to toggle a light and to get some data. And then we get into our main loop. And so what that main loop is going to do is obviously just keep cycling more or less as fast as it can. And what it's going to try to do is it's going to try to read from that auxiliary serial port, see if we've received any sort of a command. If we have, it breaks it down into some tokens and executes the corresponding function of whether we're going to toggle the light or get some data. And so just to kind of finish up the introduction to the Thonny environment, I showed you already where we can select our board. This kind of lower area down here is called a REPL area where we can send direct commands and receive feedback or anything that comes back on that standard serial port is going to report to us here. We've got our code window. These are some local files that I have on my computer. And then these are some files that are on the, actually on the sort of virtual file system in the MicroPython on the controller. So that's how that works. Now, if I just go ahead and run this code, it will go ahead and soft reboot the controller, and our code should now be running. Which means that based on what we wrote in here in our 15 lines of code or so, it should be listening for somebody to send it a command on this auxiliary UART port. So if we go to LabVIEW, maybe we can get LabVIEW to send that command. Oh, I already have it ready. So the code for the LabVIEW side is fairly straightforward. Well, let's start. Yeah, fine. So all we're going to do here is every couple of seconds or so, we're going to send it a command to get some data. And then we're going to read back a command. And based on how that command was formatted in the MicroPython code that we just looked at, we know how to tokenize that and pull out temperature and humidity data, which we can then report in this graph. So if everything works right, and if I've got my COM port set correctly here, then we should be able to run this and see some data show up. Yay, we've got data. So it looks like it's about 22 degrees in here. Feels about right. 53% humidity. If I maybe blow on this, we should be able to see a humidity spike come up. So it's actually getting real data, which I think is pretty fun. And then if we make a command to it, in other words, if we jump into doing this, where we send it this toggle light command, And in this case, I'm not really concerned with any response it might give back to me, although you could do something like that. Then if I toggle the light, we switch the relay, and we blind everybody on the first few tables. I don't know why, but I just get such a kick out of making something happen by clicking on my computer. I think that's awesome. I still do, even after all this time. So that's pretty fun. We've succeeded in receiving, using this tiny microcontroller to read an external device, and I hope we can imagine how we could extend that out to other devices or multiple devices. We've got quite a bit of I/O. We could do a lot of stuff. And then the same for the output commands. We could control lots of things. There is on a lot of these analog outputs as well. It's a little less common, more digital. But wait, this is actually the super expensive $6 version of this chip that has Wi-Fi capabilities. So what if we could do something with that extra $2 worth of value that we've got there? So let's jump back over to Thani, and I've got another demo here where we want to try to activate that Wi-Fi capability and see what we can do. Now, I will tell you, this will sort of feed back into maybe some of the limitations of these microcontrollers again, but I had originally planned this demo so that the Pico could, through Wi-Fi, just connect to the Wi-Fi that we have here at the venue. And so if we were to do that, that would be sort of what we would call a station connection, right? So as a station, I would connect to the access point in the building. But it turns out that the Wi-Fi at this venue is 5 gigahertz Wi-Fi. You probably didn't really care about that because it just works for you. But the chip on here is a smaller, lower power chip, and it only supports 2.4 gigahertz. And so because of that, I wasn't able to connect to the Wi-Fi. If you end up downloading the info from this presentation later, and you want to try this out, you can, of course, go and look up the station version. But for presenting today, what I'm going to do instead, since I can't connect to the venue Wi-Fi, is I'm going to create a very small access point on this device, right? So that means that I will, if my demo works correctly, I'll be able to set this up as an access point, and then I'll be able to connect to it as a client or as a station. So that's how this demo is gonna work. Now we can see when we start diving into the MicroPython code that compared to what we had over here, we only had a few things to import, and we've got a few more because we're adding on some libraries for doing networking, and I also added some libraries for JSON and something called Microdot. Microdot is just a library that I was able to find. There's a few of them, but Microdot seemed, in my view, to be the best one. And that's part of, I bring that up because that's part of the experience, I think, of playing with those, is looking around, seeing what libraries there are, picking one. But what it does basically is it allows us to create, with only a few lines of code, a mini web server. Maybe I'll put that in quotes because I'm not sure it fully qualifies as a real web server, but it lets us get some of the functionality of a web server. And this info here is where I'm setting up what the SSID and the password is going to be for this little access point that I'm going to try to create. This all code is going to all look very similar. We create our sensor, we create our pins, we create our time stuff. And in this small section of code, we're just going to set up and activate the Wi-Fi capability. So once we've done that, then I have a little bit of HTML here that I'm going to hopefully be able to serve up from my web server. And I use a dictionary to help us format some JSON data. And then we've got these these functions probably look familiar to you. They're a little bit different because they're formatted for our web server to call instead of just regular functions. But then we get into starting up our application. So maybe it's worth looking at this in just a little bit more detail, because what we're going to do is we're going to keep track of time. Remember, I said something about time. These DHT sensors are actually quite slow. They can only really read accurately about once every 2 seconds. And so since I don't really have any idea how often my web service is going to get hit, maybe it'll get hit every millisecond or something, I don't want to be trying to pound the sensor that often. And so I just basically check to see whether or not it's time to do a new read. If it is time to do a new read, then I just do this, call this measure command or function. And in any case, we go ahead and report back whatever the latest data is. I think part of what I'm trying to get through in this part of the demo is that you might be scared of writing MicroPython code, but there's really, honestly, not that much, right? Like, you know, I 100% agree with Jim. It'd be awesome if we could just write LabVIEW code and download it to our PyPico and have it work. That'd be great. But it's also not that bad to write 20 lines of MicroPython code. I hope this looks fairly readable and straightforward. It seemed like it was to me. All right, so if we go ahead and stop what was running on our microcontroller and instead run this new thing, I hope that this is, let me see if I can make that a little bit bigger now. So what we see here is a little bit of feedback. This is coming through what I was kind of calling standard input before, where this controller, the MicroPython code, is writing things out in these print statements, and we're getting it come back on our console. So it thinks that it went ahead and started a web server on that address and port. So if it's not lying to us, then we should be able to switch over here to LabVIEW, open up our LabVIEW demo, and see if we can kind of handle the other side of that communication. All right, so this code obviously is going to look pretty similar at trying to keep things parallel so we can see the progression. But now, instead of doing a serial read or whatnot, we're going to make this IP address web service call through just a simple HTTP GET. Assuming that we get something back from our HTTP GET, we're just going to run that through a JSON parser and get our data out. So basically, 2 primitives on LabVIEW. And then the similar thing is if we wanted to try and send a command, all we do is format our web service URL and send it a post, is all we have to do. So that should be pretty straightforward. Hopefully my demo will work and we'll be able to connect up. Or maybe not. Maybe we'll try it again. Oh, I forgot an important step. I apologize. I never connected to the access point. Right? So this is something, because it's not doing it, you know, I could potentially already be on the Wi-Fi, but I need to look and see if I can find, oh, is that big enough for people to see? So I purposely named it with 3 A's at the beginning because there was a lot of access points in this room, and I wanted us to be able to find it pretty easily. So if I connect to that, this demo should probably work a lot better, and it'll kind of give you a better feel for what we need to do. If I had been able to just connect that to the house Wi-Fi, and if I had already been on the house Wi-Fi, things would have just worked. But because of the way I'm doing this, I need to connect to it. I think part of the reason this takes a long time is that my laptop is assuming that it's going to be able to get to the internet through this thing. And it's trying to figure out, hey, I can't get to anything. But in just a minute, it'll give up on that and figure, well, I don't know what you're doing, but you don't got no internet. Anyway, so once we are actually connected, let's try this demo again, see if things work. And now we're getting some data from it, and I can put my hand on here to try and increase its humidity. The temperature responds a little more slowly, so you don't always get really instant feedback from that. But I think we're working here, we're getting data, and we should probably even blind those people one more time, make sure we can do that. Yeah, poor Alan, he hates it so much. Anyway, so now the part of the thing is you guys might think that I've got some trickery or something, because I'm actually hooked up to this. Is it really going through Wi-Fi or not? So I wanted to kind of try to encourage you to participate. And so since this is Wi-Fi, you should be able to take your computers or your phones and go connect to that same SSID that I just barely showed you, put in that same password, and hit that IP address, and you should be able to see the little web page that I posted to that web server. And in addition to being able to query the current data as far as the temperature and humidity and stuff, I should also note that this is a fairly small device, and it's not going to be able to handle 100 connections. So there's a bit of a race, I guess. And to sweeten the pot, I have a few giveaways here. I've got a few little gift boxes, and each of these gift boxes has in it essentially the stuff that you would need to reproduce this demo. Not the relays and the light bulb and stuff, but you've got a microcontroller, you've got a DHT sensor, you've got a little breadboard, and you could mock up everything that I'm showing you today, with the exception of you have to do an LED instead of a real light bulb. And so if anyone has been, I'm gonna jump out of this and I'm gonna switch back over to here so that I can monitor. We've got some people who apparently have been able to get in. I'm seeing some people getting some data, reading the sensor. But you'll also notice on that page there's a little name entry, and I thought it would be fun if people could put their names in there if they want to win one of these. I have 6 of them, and I thought this first 6 people who put their name in could win a prize.
What's the IP address again?
Sorry, I will switch back to this. Maybe I can kind of maybe show both here a little bit.
Keeps teasing me.
Yeah, I mean, it's going to be a bit of a fight, because I think I read in the documentation it can really only handle 5 simultaneous connections. So I guess I will ask, if you do succeed in getting in, put your name in, enter your name, and then disconnect from that access point, and hopefully somebody else can get in when you're out. That'll help us to kind of serial our way through that. And I didn't really tell you, but as another little enticement, if you succeed in putting your name in, I have as a side effect that this light's going to turn on. So Alan just is now motivated not to do it, I guess, but.
Everybody gets to blind Alan.
Yep, everybody gets to try to blind Alan. So, okay, people are getting stuck on the SSID.
No, I enter the credentials you have up there.
Yeah, it's not allowed.
I can double check. Let me just double check this.
Can you see how many people have connected?
I'd have to count through this list. All I'm really logging here is who has clicked on the get data. Oh, or that could actually have just been from me. Let me go ahead and clear this. Well, all right, then I want to at least show the capacity here. Let me see if, so I'm still connected. So let me just show you what I think you should be seeing if this were working. Or if you're able to connect, I guess is what I mean. So if I go to 192.168.4.1, then I get this is my web page, and I can put my name in, and I can click submit, and the light will come on, and I'll go ahead, just because I don't want to blind people so much, I'll submit my name one more time. And in this interface, I see a couple of get commands, and I see that somebody submitted a name. And to make things a little easier on all you all, I will go ahead and disconnect from that now. Maybe that'll free up one extra resource. So if I understand right, people are getting stuck on this ability to even connect to the access point, right? It's not, you're not able to get past that.
Probably too far away.
I don't honestly know what kind of range this has. I'm guessing the people in the first couple of tables have a better shot at it, but even they don't seem to be able to. I had a hard time pre-testing the range of that, so. Oh, yeah, there's a good idea. There's a good idea.
Where's Dorman's spectrum analyzer?
Oh, did you get the web page? Yep. Yeah, we are almost up here. Yeah, just put your name in and hit submit. Yes! Yes! We got the actual audience participation to work. And apparently someone named Tyler was the first winner. Make sure you disconnect then so somebody else could try to get in. We'll see if anyone else is motivated enough.
They're also we don't block out here. Turn it off, please. I already disconnected, sorry.
Well, here's what I can do until we get something else. I'll still hear it click if. Maybe I should have, instead of toggling it, maybe I should have had it just do a little blink or something. That would have been probably smarter. All right, well, I'm going to let people keep fussing with that for a minute, and I'm just going to say a few more words to kind of wrap things up. And hopefully we'll get 6 people who succeed in beating their way through this network limitation. So I've got a list of links here. If any of you either win a prize or you just want to grab a Pico, like I said, they're only $4 for the cheaper one or $6, and you want to try any of this, there's links of how you would get it all set up right here. And then I know already I can fill in one of these winners, Tyler. And I guess I would just like to open it up for any questions that people have about any of this. Oh, people still need to see this. That's like I can show this while I'm inviting questions. Oops, oh, shoot. Sorry, I'll get it back up. Yeah, I mean, has this provoked any thoughts in anybody? Yeah. Do we have mics for people?
I lost the connection. Okay, so I love Arduino. I just love them. And I've even deployed some test systems using Arduinos.
You have? That's so awesome.
Like they're in production, and it was really cool. I could just use. I'm using it as a proxy for the product, and I'm just grabbing the C code off of the product and putting little snippets in there to do certain functions. And I've been doing that for years now. And one of the things that we used that was really helpful was a toolkit called LabVIEW Interface for Arduino. And it got superseded by the Links toolkit, which was more about, hey, let's write LabVIEW code and try and put it down onto a target, which is cool too, but it's not what I needed to do because I still need LabVIEW to interface to like test stand and get data up to our production database and whatnot. So now I'm seeing this stuff coming out, and it's like, okay,
somebody did it.
yeah. So, so
Or maybe two
what was
people
cool
did.
about the LabVIEW interface for Arduino is it basically gave you that framework, right? Of being able to just talk to the Arduino and toggle
Thomas did it 3 times.
pins and do all sorts of stuff.
Sorry.
No, that's fine.
But now, as I'm seeing the Raspberry Pi stuff, I'm thinking, it'd be nice if we started, if there was a similar framework for Raspberry Pi, we could just load it with some code and then make it, have it interact with your LabVIEW code very much like that. Plus, the other thing is that I'd love to see the LIFA brought back to life because it was a great piece of, I thought it was a great piece of firmware. And in fact, at one point, I think even SparkFun offered a toolkit that said, hey, here's like a LabVIEW, here's LabVIEW and an Arduino, and you can do this on your own. Anyway, I don't know if that's even a possibility, if NI would even consider doing something like that, but it was just a really, if they want to try and get into that hobby market and penetrate it again, I would think that would be a good way to do it.
I think that is interesting. I didn't really talk about links, but I have looked at that and I've used it before. I don't know. I think there's definitely a place for it. From my perspective, it was a little bit annoying that you kind of had to maintain that connection in order to do, like, the logic of your code was still kind of running on the host side or on the LabVIEW side. And I wanted to have at least the ability for it to just sort of run and do its own thing autonomously, which this sort of thing would. I didn't really demo that either, but you could set this to just start up and it could just run all on its own. It doesn't need LabVIEW to be there. But yeah, I think the more things that we could get going, and if you wanted to start a project to write the code, what you'd really need to have is, you might not want to do it in MicroPython per se, although you probably could, but if you had a much more robust version of what we have here, instead of just these 2 things that we do, if you had a configurable list of all the pins and everything, you could probably write something like that could function as the firmware for a new and improved links type interface. But I think people are just kind of rolling their own as needed for what they want, sort of like what we've got here. If I update my list here, we've got Thomas and Megan. Oh, we got 2 different Thomases. Or no, it's not. It's just Thomas many, many times. Thanks, man.
Sorry. I disconnected, I promise. Thomas? Oh, an extra white space. Oh.
Yeah, Thomas with the white space. All right, well, I got a few other kits. Maybe I'll just sort of, yeah, good question?
Well, I've been daunted. Hold on.
I've been daunted by the number of libraries that are out there. So you just showed a MicroPython code that had just the right libraries that you needed. How do you sort through that plethora of opportunities and figure out what works and what's worthwhile?
Yeah, I was tempted to put in, but ended up electing not to, some sort of a slide about how to improve your Google Foo. But I think for me, the basic way is to know what I want to do, Google that at least up to the point where I can figure out what the appropriate terminology in that industry is, right? So in this specific case, I knew that I wanted to create a web service on MicroPython. And so with that limiting set of parameters, I was kind of able to track in on maybe 4 or 5 different options of things that might sort of do it. Some of which were libraries that I could download, some of which were, hey, here's some sample code of how you could try to roll your own, and that sort of thing. And I ended up just kind of trying a few of the ones that looked most, that had the features that I would care about. because I knew I wanted to be able to have like a text input, and I wanted to be able to do HTTP gets and posts so that we could do that sort of things easily through LabVIEW, and I was looking for JSON support. So I guess maybe the short answer to your question is try and be as specific about what you want. Like if you just Google, I want to talk to a device, that's going to lead you to some pretty broad and unhelpful suggestions. But if you know I need a web server for MicroPython, that'll probably get you close enough. All right, well, my time is out. I think what I'm going to do is check one more time to see if I've got any more. Oh, we got Jim Fowler managed to get in. Yeah, with my I shouldn't have turned the light off because then people don't know if they made it. But I'll just do Jim Fowler. And any of the people who are standing up here trying to do it and didn't get in, maybe we'll have a arm wrestling competition for them. But I think we might have enough. So, all right. Well, anyway, thank you all very, very much. If your name is on the list, or if you've been trying and trying, come on up here, and hopefully we'll have enough prizes for all those people. Thank you very much.
A special thanks goes out to Kevin Chirey, Quentin Q. Aldridge, Mark Balla, and Jeff DeBoer for their help in filming. And of course, this GDevCon NA 2023 wouldn't be possible without all of our sponsors. Thanks.